First, spin up the tweet service to publish to Kafka pipeline on AWS. Two mainstream ways on AWS: Kinesis, AWS native, or MSK, manage Kafka. I'll show both console steps and minimal CLI examples. A. Using Kinesis data streams, fast to set up, fully AWS manage. Console clicks. First, AWS console, to services, to Kinesis, to data streams, to create data stream. Second, give name, tweets-stream, choose shard count 1 for small dev, then create. Third, create a producer in your app that writes JSON events to tweets-stream. Fourth, create Lambda consumer, Kinesis, add trigger on your Lambda function. Console allows connecting it to the stream. CLI for quick. In Bash, you would create the stream, AWS Kinesis space create dash stream space dash dash stream dash name space tweets dash stream dash dash shard dash count space 1. Then comment hashtag put a small record base64 payload. Here's the command: AWS Kinesis put dash record dash dash stream dash name space tweets dash stream. / the next line dash dash partition dash key space user dash 123 / next line dash dash data and argument echo dash n quote opening semi-curly quote user quote opening quote closing quote opening quote user closing quote colon opening quote u1 closing quote comma opening quote tweet opening quote colon opening quote hi closing quote closing semi-curly bracket 1 quote closing 1 quote, and then or symbol, then or vertical line base64, then closing parenthesis. Your producer code uses AWS SDK put records / put records. Lambdas are attached as stream consumers and get batches. B. Using Amazon MSK, manage Kafka. If you want Kafka ecosystem, Kafka clients, Kafka Connect, Flink. Here is the console clicks. First, console to services to Amazon MSK to create cluster. Then choose provisioned or serverless, name tweets-msk, then set broker settings and VPC, then create. Then after cluster is active, get bootstrap brokers, MSK console. Third, from your app, ec2/eks/local dev, run kafka-console-producer with the bootstrap brokers to publish, or use a Kafka client library, Java or Node or Go. Sample CLI or console producer, run from ec2/eks with Kafka client installed. In Bash, kafka-console-producer space -- topic space tweets space -- bootstrap - server space less than brokers -from -msk greater than. The next line, opening semi-curly bracket, so this is type JSON lines, quote user colon quote u1 comma quote tweet colon quote hello world closing semi-curly bracket. Second, fan out workers, real world implementations and examples. What they do: consume the single event tweet and push copies into each follower's timeline store. Where they run: AWS Lambda, ECS/EKS services, or dedicated worker VMs. Example real world flows. Option A, serverless fan out, small or medium projects. We have API gateway HTTP to Lambda auth, which handle auth, validate, produce to Kinesis. Then we have Kinesis stream, tweets dash stream. Then we have Lambda consumers, parallel. Then we have write into DynamoDB per user timeline or Redis per user cache. Pros, low ops, auto scale with Kinesis or Lambda. Good for startups, moderate traffic. Option B, Kafka plus workers at scale, Twitter style. We have producer, which is tweet dash service to Kafka topic tweets. Then next line, fan out worker fleet, which is K8s or ECS consuming the topic. Then next line, for each follower. Next line, push to Redis sorted set timeline or write to sharded DB, DynamoDB. Pros, great throughput, control, stable for huge traffic. Real example, Twitter historically used a fan-out worker system to compute per user timelines. They later evolved hybrid approaches. Many large companies use similar jobs. Option C, stream processing, TikTok or Meta. Kafka to Flink or Spark streaming to real-time transforms or aggregation to materialize timeline. DB. Pros, Windows joined, stateful processing, scalable. Use when you want more complex enrichment. Rank, dedupe, ML features. How workers write a copy? They typically push a small record keyed by recipient user ID. Example, Redis command. ZAD timeline colon U123 less than timestamp greater than then less than tweet dash ID greater than, or DynamoDB item put slash timeline table. Next line, opening curly bracket, so this is a JSON, quote user ID colon quote U123 comma quote TS colon 168 dot comma quote tweet ID colon quote T dash 456 comma quote author colon quote U1 comma quote body colon quote etc. and other key values. Third, hedge request. What precisely happens and what's discarded? Hedge request equals send duplicate request to multiple replicas and use the first one. Client fires request A to replica 1 and request B to replica 2 or to cache versus DB. Which returns first is used by the client, other responses are ignored. Important, ignored by client are not equal never process. Servers still process the request and produce responses. CPU work, maybe DB updates. Servers may cancel early if your server supports request cancellation. gRPC, context.cancel, but cancellation isn't instant. Where do discarded responses go? They are simply unused at the client. Servers might log them or emit metrics. If you want to avoid wasted work, you implement cancellation propagation, idempotency, or early abort logic. Visibility or storage, server log outcomes to CloudWatch or Elasticsearch, OpenSearch or S3. Traces are recorded in X-ray or OpenTelemetry exporters. Trace IDs let you see which request returned first. Why hedging helps stay latency? You remove the single slow replica from the game. The cause is extra work. Increased load, so use it selectively for important reads or at high percentiles. Fourth, where do you record and monitor histograms in AWS? Real tools plus algorithms. AWS services, Amazon Managed Service for Prometheus, AMP plus Amazon Managed Grafana. Collect metrics, compute histograms, store them long term. CloudWatch, native metric percentiles, P90/P99 and CloudWatch metric streams, ship raw metrics to Kinesis/S3. AWS, X-ray, distributed tracing, per segment latencies, not full histograms. OpenTelemetry plus AMP/Grafana for production grade observability. Algorithms used while low memory. HDR histogram, very common. Compact, fixed size buckets supporting high precision across wide ranges. It's extremely fast, merges easily across instances. Add histograms, small memory footprint. T-Digest, store centered clusters, gives accurate high percentiles with small memory. Why not raw arrays? Sorting raw latency costs ON log n and memory ON. HDR histogram/T-Digest compress the distribution into a few kilobytes. Merge easily across machines and let you compute P50/P95/P99/P99.9 cheaply. Real implementation. App records latency metrics as micrometer or Prometheus histograms, or histograms is exported by language libs using HDR. Prometheus/AMP stores them. Grafana dashboard draw percentiles. FIP, bitrate, chunking, FFmpeg. How YouTube does it? Practical. Bitrate equal bits per second for a video or audio streams. Kilobytes per second, Mbps. Higher bitrate equals to higher quality, larger file size, and more bandwidth needed. YouTube transcodes every uploaded video into multiple renditions, resolutions plus bitrates, i.e. 240p at 300 kilobytes per second, 480p at 1000 kilobytes per second, 1080p at 5 Mbps, etc. Chunking plus ABR, adaptive bitrate. Videos are packaged into short segments, i.e. 2 to 4 second chunks, and served with a manifest, dash, or HLS. The player requests chunk and monitors download speed or latency and chooses next chunk at higher or lower bitrate, ABR. If a chunk takes too long, player switches to lower bitrate for subsequent chunks that avoid stalls. Quick plus HTTP/3 helps because it avoids head-of-line blocking and re-establishes quickly. Chunk fetch latency improves. FFmpeg, example, general multiple renditions. In Bash, you have ffmpeg-i input.mp4 /next9-map0-c:\v livex264-b/v:0 So repeat that, just change the k with 1 to 100k and the resolution to 1 to 80 x720 and to 128k, and the name is out_720.mp4, and just repeat that for 1080 resolution for 1920x1080. Those outputs are then packaged into HLS or dash segments and uploaded to CDN. Walk through option A or B or C. Now reads or writes execute end to end. Option A, modern serverless. User to API gateway, post or tweet. To Lambda, auth or validate. To put record, to Kinesis, tweets dash stream. To Lambda, consumers triggered by Kinesis. To for each follower, write to Dynamo or Redis, timeline entries. Read path, timeline dash service, API, reads per user timeline from DynamoDB or Redis. To return to click. Write cost, higher, fan out write, or work, and asynchronous eventual consistency. Read cost, cheap, O1 read, AWS building blocks, API gateway, Lambda, Kinesis, DynamoDB, Elasticache. Option B, Twitter scale, Kafka plus workers. So we first have producer to Kafka topic tweaks. Next line, worker pool, ECS or EKS consumes. Next line, writes to Redis sorted sets, ZAD, or DynamoDB batches for user timelines. Next line, read path, timeline read is a single Redis or Dynamo read. More control, workers can batch writes, dedupe, retry. Use Kafka consumer groups, partitions keyed by author ID or region. Option C, TikTok or meta style. Producer to Kafka. Next line, Flink or Spark streaming for enrichment. Features, ranking. Next line, output, materialized timeline shards, sharded DBs. Next line, read, timeline dash service queries, a single shard or partition or a few replicas. Advantage, advanced real-time enrichment or ranking, ML features during write-time processing. 7. How TikTok for you avoids tail latency. Short summary. Heavy precomputation, candidate generation and ranking are pre-computed offline and in streaming pipelines. Material views. Low latency stores, timeline served from highly cached, sharded stores, Redis or Aerospike close to edge. Ranker is fast. Inference often uses compact models or cache features, so online scoring is cheap. Fallbacks and hedging. If ranker or candidate service is low, return cache, result, hedging plus cache fallback. Edge caching. Caches frequently requested feed pages and revalidation happens asynchronously. Practical answers to your specific sub-questions. CLI command or GUI setup, publish Kafka. Use Kinesis Easy or MSK Kafka. CLI examples above: AWS Kinesis create dash stream and Kafka dash console dash producer against MSK bootstrap brokers. Are this real world? Absolutely. Big companies use Kinesis or Kafka plus workers plus Redis or Dynamo. Twitter use fan out workers and materialized timelines, so do many social platforms. If hedge request discards slow response, where does the packet go? The slow response still arrives at client or is generated server side. Client ignores it. Servers may be cancelled if you propagate cancellation. Otherwise, they complete and push logs or metrics. Do they keep discarded packets? No special discarded packets storage. They may have logs or traces, CloudWatch, X-Ray for debugging. Requests and responses normally are ephemeral. Important events are persisted to logs or S3. What AWS service provides histogram? Use Prometheus/AMP plus Grafana for real histograms. CloudWatch for basic percentile metrics. Use HDR histogram or tdigest libs in your app or middleware to push compact histograms to prompt. How does YouTube fetching different bitrate relate to FFmpeg? FFmpeg is used to pre-generate renditions at multiple bitrates or resolutions. The player picks the bitrate per chunk based on network conditions. How do these architectures process read versus write? Writes trigger streams events and heavy fan-out processing. Expensive, done once. Reads are cheap lookups into pre-computed per user timeline caches. This is the write-heavy or cheap read trade-off we discussed, chosen because reads are greater than writes. Quick practical checklists you can execute now. If you want to prototype, create a small Kinesis stream, tweets the dash stream, AWS console or CLI. Deploy a Lambda producer or simple node app that puts records to the stream. Create second Lambda consumer that reads and writes to a local Redis, Elasticache, or DynamoDB table as a timeline store. If you want Kafka, use MSK serverless, no broker provisioning, or a single broker MSK dev cluster. Run Kafka-console-producer from an EC2 that's in the MSK VPC. Observability, instrument latency histograms with HDR histogram or Prometheus client, Micrometer for Java, script to AMP, view in Grafana.